The Prepper Podcast, episode 34.
We've got to know whether or not they're presidents of Christ.
The American people would never vote for socialism. He said, under the name of liberalism, the American people will adopt every fragment of the socialist program.
The Prepper Podcast is an up-to-date survival podcast based on military, wilderness, and modern-day survival and may be found at theprepperpodcast.com. I am Ken Jensen, and this is the podcast about everything survival. And my goal is to teach you strategies on self-reliance and to develop survival skills and critical thinking in everyone, resulting in a more resilient and more enjoyable life. This is episode 34, and it's going to be a good show today. Remember, last time I told you that we were going to talk about power consumption and energy in your home, considering alternative sources, what you need to know about batteries, everything you need to know about inverters, and other items that we need to create a good battery bank, and then possibly a little bit about generators. All right, and today's show notes may be found at theprepperpodcast.com/034. Now for the housekeeping. I want to remind you guys about Zello. Go to theprepperpodcast.com/Zello. I know that I had an email from one of you saying that my link was broken to my Zello channel and that you could not find me. Well, the issue with not being able to find me was the fact that Zello, for some reason, had decided to change the way that they did the channel URL. But I can promise you that it is redirected now. So you can go to theprepperpodcast.com/Zello and you can get to my Zello channel. And if you're searching for my channel on Zello, go ahead and search for Clever Survivalist. Okay? That's what the channel's name is because that's what my blog is. And I started my blog well before my podcast. I did go ahead and create another channel called the Prepper Podcast just in case people don't hear this intro and they decide they want to go to the Prepper Podcast in Zello. But occasionally I think I'll just go in there, and if somebody's on, I'll let them know that the main channel is my Clever Survivalist channel, okay? But if you just remember theprepperpodcast.com/Zello, then you'll be able to get to my Zello channel. I hope that clears everything up as to why nobody has been able to find my Zello channel. All right, and iTunes. Please remember to go to iTunes and give me some ratings. I appreciate all of the 5-star ratings that you guys have been giving me. It gives me hope and it keeps me going strong. I really do appreciate it. It makes me feel good about what I'm doing here, and that is always key when it comes to doing a podcast, because for every 1 hour that I put into a show, you have to expect that I've probably done about 5 to 6 hours of prep work minimum. And for someone who works a full-time job, and not only full-time, but probably works about 60 hours a week, and then 3 hours a day is driving, that's a substantial amount of time to put into show prep. So, remember, go to iTunes, give me a rating. Also, this show should be coming out on Saturday. Unfortunately, I couldn't get it out in time on Friday, so I thought I'd give you a good show on Saturday. What that means is tomorrow is 6/15/2014 is Father's Day. And don't forget that we started doing a new news segment with Jay Bradbury of PreparePDX.com. And let's go on over to Brad and see what he's got for us this week.
Thanks, Ken. And now for your news flash. I have a safety alert. With summer coming upon us and people opening up the windows, many are not aware that children only need 4 inches to fall out of a window for injury or maybe even death. So if you have young ones in the house, please look up child safety windows on any search engine. On to other news. There's a new barter website that opened today called Eartheneers. That's Earth, Ineers, where you can barter with people in your local area. If you're Portland, Oregon, look me up. Alright, now on to the disaster site. Hawk Key Davis on YouTube has a new video, Signs of Change the Past Week or so, 2014. Large-scale disasters continue to strike with regularity, causing catastrophic damage to multiple areas, leaving hundreds of thousands displaced. Also included are some dramatically breathtaking weather events caught on video. Alright, that's your news flash. Back to you, Ken.
I think you guys should go over the show notes and click on that link to go to www.eartheneer.com. And I think that you guys should follow that because I checked it out, and that's actually a pretty cool barter site. I want to thank Jay Bradbury for all the effort that he puts into these news segments, and I want to thank him for the link to that barter site. And now let's get on with the discussion. Like I said, I think today is going to be a really good discussion. We're going to talk about awesome things like what is the basic concept for great use of a battery bank with a generator. We're going to talk about what you need to know about batteries, and you're going to have so much of an understanding that you'll be able to go to Walmart or Sam's Club or anything like that, and you're going to be able to point to that battery and say, I want that specific battery for my battery bank. You're going to be able to tell the guy behind the counter, that is the battery I want. You're basically going to have a 1-year degree in just batteries themselves, how they work, and what batteries you want, why you want those batteries, and you're going to know exactly how to choose the best battery for your battery bank. So with that, let's get started. I want to remind you guys, before you guys comment on today's show notes, before you comment or leave me any emails or anything like that saying that I left something out, I want you to understand that today is not about the special batteries that we're going to use. Okay, today is not about any crazy special batteries. All right, today is about consumer level batteries that we can purchase and use for a reasonable amount of money for our battery bank. All right, and if it seems to be a little awkward in the way that this show flows, I want you to understand that about every 30 seconds I'm pausing this because I'm coughing like crazy because a while back I got a cold and I am still dealing with that. I think I ended up getting a little bit of pneumonia with it, and so now I've got this gnarly cough. I feel fine, but I can't stop this cough. My lungs are constantly tickling. So just understand that if you notice a little bit of break in the flow, that kind of thing, that it may be because I paused it so I could cough, so I'm not coughing in your ear. But I was saying that we need to use regular day-to-day batteries that we can get at a local store and we can use in our battery banks. So let's go over some of the battery types. We have flooded, the first battery type that I'm going to talk about is flooded lead-acid batteries. Flooded lead-acid batteries are like the batteries that you're going to find in your car, in your lawnmower. They're going to be like the batteries on a boat, in golf carts, and even the 400-pound 2-volt telecom batteries that you find, the special backup batteries. Those are flooded lead-acid batteries as well. And I know that you guys are probably going to wonder what the difference is between a normal flood lead-acid battery and a maintenance-free battery is. Well, a maintenance-free battery is actually just a regular flood lead-acid battery. The thing is all they did is they put the caps on so tight that nothing can get out and you can't get in. And they also, some of them may not even have caps, but all it is a flood lead-acid battery. All right? Now, I know that I don't want to get real in depth with these things because I want to keep it simple, but understand that inside you've got plates. You've got a negative plate and a positive plate. The negative plate is lead. The positive plate is lead dioxide, okay? These are the different plates that you have on the battery, and then they are put inside the battery chamber, and this battery chamber is flooded, hence the name flooded lead acid. They pour in a solution that is 65% sulfuric acid and 35% water, and they flood this chamber with these plates in it, and these plates are completely submerged in this solution. So you've got a flooded lead acid battery, you've got a positive lead or a positive lead dioxide, a negative lead, and it's flooded with sulfuric acid and water. All right, you have 12. You have a 12-volt battery. A lot of these are 12 volts, and if you have a 12-volt battery, it's actually like 6 little bitty 2-volt batteries. All right, I talked about those 2-volt telecom batteries. That's just because these are really big single chamber batteries. But the 12-volt battery is 6 little bitty chambers of 2-volt batteries, and they're connected inside the battery to make a 12-volt battery. And then the 6-volt battery has 3 chambers that are 2 volts. All right, flooded lead acid batteries are spillable batteries. Okay, let me repeat that. They are spillable batteries. They have caps on them. You can refill them, and because you can refill them, then you can release what's in them. All right, so the next thing we're going to talk about is what's called a sealed lead acid battery. And a sealed lead acid battery is also called a gel cell battery. Now, these are the ones that you're going to find in like your Power Wheels, those little jump box charging packs that you can keep in your car that help you jump if your battery goes out. They use little sealed lead acid batteries. Sorry, hold on. I had to pause for a second there just so that I could hack up a lung, but I'm okay now. These are the ones that you'll find in Power Wheels. You're going to find in your car jump boxes. Small sealed lead acid batteries. These are in your UPS power. Your UPS. These are your power supplies, your backup power supplies for your computers and stuff. The ones that you don't want to use as backup power because they sit there and they beep at you the entire time, and they don't have a lot of storage capacity, so they won't last very long. Those are just meant to shut your computer down before it dies, okay? These are also in your alarm system. If you have an alarm system in your house, which you probably should, if you have an alarm system in your house and it's got a backup battery power supply, which it should if it's an alarm system worth anything, where your main panel is, usually there's a battery that's connected to it, and that's going to be a sealed lead acid battery as well. Emergency exit lights. So if you go into like a building or something like that and you see these emergency exit signs and stuff like that light up, those are run by regular power, and they have an electronic board inside that will switch over to the sealed lead acid battery. It keeps the sealed lead acid battery charged up, and then when power gets lost to the light, the electronic board just switches straight over to those sealed lead acid batteries. All right, and the electrolyte inside is a gel. That's hence the reason why it's called a gel cell. All right, now the benefit of a sealed lead acid battery would be the fact that it can work in any position, any configuration. I actually work on, or I used to quite a bit until I got an advancement in my job title, but I worked on these emergency exit lights all the time. And we would have these things upside down. We'd have them on their side. We would do all kinds of stuff in these things. And we had them in temperatures that were close to 200 degrees at times. And they would last a while before they would expand and just stop functioning because it would get so hot. But it's a fairly robust battery. The biggest problem that I have with sealed lead acid batteries, and the biggest problem that most people have, and they just don't realize it, is these batteries are like a year old before you get them. I mean, they're built overseas, and then they're stuck in a warehouse, and they're shipped to a manufacturer that puts these batteries in whatever electronic component uses them, and then they sit in a warehouse, and then they go to the dock, and then they're shipped over here, and then they sit in a warehouse, and then they're shipped to wherever you're going to purchase that product. All right, so these sealed lead acid batteries are generally over a year old before you even get them, and they only have a life of like 2 or 3 years. They usually last a little bit longer than that, but they only have a suggested life of 2 to 3 years, and a year of that's already gone. So that's the biggest problem with these sealed lead acid batteries. I don't know, but I don't think any of these are made in the U.S. All right, so these batteries are old before you even get them. Usually they're smaller. They're smaller than a flooded lead acid battery. The problem that's a problem, right? Because the smaller the battery, the smaller the capacity. It's pretty easy to tell that. The smaller the battery, the smaller the capacity of the battery. So the biggest sealed lead acid battery is probably going to be similar to the smallest flood lead acid battery, and they're going to be 2.5 to 3 times the price. So it's not really worth it. And these batteries are being replaced by absorbed glass mat batteries anyways. And that's going to get us over to our next topic. All right, the next topic is absorbed glass mat batteries. Okay? Now, these are considered liquid batteries, but they are non-spillable just like the gel cell batteries. All right. We also call these AGM batteries. Okay. So if you're doing a Google search for them, you may just look up AGM battery. All right. Don't confuse them with a gel cell because these are completely different batteries. They are created a different way. It is a liquid electrolyte. It's not a gel electrolyte. And this liquid electrolyte is absorbed by this AGM material on the plates like a sponge. Okay, so this AGM material is it's fiberglass. It's like a fiberglass sponge-like material. All right, these batteries are so robust. They are so robust that they are legal to ship on jetliners. All right, and they are considered safe for children. All right, in my opinion, they are the battery that you would choose if safety is important. All right, so these batteries, I mean, you could knock them off the table and they'll be, I can't tell you that they would function anymore, but I can tell you that they should not spill all over your floor. All right, so these are very robust batteries. The electrolyte is absorbed by the AGM material, and these are actually designed to be used on fighter jets. That's the first use of an AGM battery was on fighter jets. So because of that design, they can take all kinds of abuse, and they also can be used in all the different configurations, just like a sealed lead acid battery could. These are great for people with children, like I said, and they can be freighted. They can be shipped on truck without a hazmat DOT placard. So that's pretty cool. It doesn't require any special placard to be shipped because it's not considered to be hazardous material. All right. The chemistry is actually better than a flood lead acid battery as well. It's a more efficient, and it's just a little bit better, okay? So it's a more efficient battery, and due to the way that it is built, it is deep cycle in nature, and we'll get to that. And the efficiency, though, let's say that you are, it is, 20% more efficient or something like that. It's not worth the price because, once again, the price is about 3 times the price of a flood lead acid battery. So for economic reasons, you don't want to choose one of these. You would go with a flood lead acid battery because it's going to be 2 to 3 times cheaper. So if you wanted to, you could save the money that you would spend on one of these. You could just buy more flood lead acid batteries, and you have 100% more efficiency than, or 100% more capacity instead of just 20% more capacity. So the only reason why you would want to use these would be for safety reasons. Now, there are a lot of different future battery options, but those are not options now. I mean, lithium technology has been coming a long way. So you've got lithium polymer batteries. They're also called lipo batteries. And then you've got the lithium phosphate batteries. And if you want to look up by the chemical symbol, you can look up FeLiO4P, or you can just call it lithium phosphate. All right. The Fe is for ferrous. That's a ferromaterial, or otherwise is iron. And then Li is for lithium. And then in the lithium polymer, the lipo, the Po is for the polymer. But then O4P is for oxygen and phosphorus. But that is O4P, which is phosphate. Or it's also known as PO4, is phosphate. But that's about as far as I'm going to go into the chemical symbols and stuff for those, because we're not even talking about those batteries, and I don't want to get too involved in the chemistry. I just want to get you guys where you know how to use them. So let's talk about the better batteries, okay? Flooded lead acid is about half the price of an AGM, or absorbed glass mat, or a gel cell, otherwise known as sealed lead acid batteries. All right, the AGMs and the gel cells are non-spillable, so they're really great safety-wise for your children and your pets. I use flooded lead acid batteries. I use golf cart batteries. The battery sizing. All right, so I'm gonna get kind of a little bit technical here. And I'm going to tell you about some different battery sizes and the jargon that goes along with it. You have something called group sizes, all right? And the group sizes that are generally available at a large store would be groups 24, 27, 29, and 31. Now, group 24 would be like a small car battery. Now, these are generalized, all right? These are 100% just generalized rules of thumb, and they could be wrong. But 24 is usually a small car battery. 27 is usually a mid-sized car or truck. All right, so an average mid-sized sedan or a small truck. And then 29 to 31 is usually a big truck, like an F-350 type thing. And some of them may have two 27s or something like that. Now, you want to get a 31. These are size, okay? These are the size, the physical size of the battery. And here's the thing. It's so closely related to capacity. The bigger the size, the bigger the capacity. Okay? Now, there are some things that they can do with chemistry that will adjust it up and down a little bit. But in general, and as far as you actually need, just know bigger size is more capacity, and it is almost 100% accurate. Okay, so you want to get a group 31 battery if you can, but you can go with a group 29 if you have to settle and you can't find a group 31 battery. All right, so I told you a minute ago that I was going to go over deep cycle batteries. So let's go over deep cycle batteries. Let's see. Deep cycle batteries are going to be meant to be used from full charge to full discharge. I kind of wanted to go into some technicals there. We'll get into that here in a little bit, but I don't want to get too much into that yet. Deep cycle batteries are meant to go from full charge to full discharge. All right? They are not car batteries. There is a big construction difference in these batteries. All right, and it has to do with surface area of the plates. All right, in a car battery, you have a large cold cranking amps. You'll hear that spouted off. higher the cold cranking amps, it usually means that there's more plates, but they're smaller plates. All right, so the plates are smaller in construction, but there's more of them, so you can pull more. You can pull more at one time. What that means, though, is that those batteries, when the chemical changes start to occur, it is more detrimental to pull the batteries down and to pull their electrical capacity, to pull that down below 50% is very detrimental in a car battery because of those thinner plates. A deep cycle battery has a larger plate construction, okay? And let's just give you a quick number to show you how the construction really does affect it. We already know that car batteries have the cold cranking amp advantage over a deep cycle battery. But what you don't know is that you can go from full charge to full discharge and back to full charge about 12 times in a car battery. That's it, about 12 times. But you can go 200 times. All right, 200 times you can go from full charge to full discharge in a typical deep cycle battery. Now, AGMs and gel cells are typically deep cycle in nature. They are usually designed to be used in a deep cycle application. All right, so the chemistry and everything else and the construction of the plates are all based on deep cycle. So the majority of the time, if you get an AGM or a gel cell, it is going to be a deep cycle battery. Now, because we have talked about the fact that you're not going to go with a gel cell because it's too small and it's too old, and you're not going to go, let's just say, we're not going to go with AGM batteries. We're going to go with a flooded lead acid battery. And then, of the different lead acid batteries, you have deep cycle batteries and regular car batteries and that kind of thing. And we already said that we're going to choose a deep cycle battery. All right. So which deep cycle batteries do you want? Well, that depends. I will tell you that what I have in one of my banks is Duracell GC2 golf cart batteries. Because they have a robust construction, they're cheaper than the gel cell, seal lead acid batteries, or the AGM batteries. All right, and they are 6 volts each, and they're 120 amp hours, give or take. All right. So we'll talk real quick about some golf cart battery sizes. All right, marine batteries, you kind of just pay attention to the amp hour rating and stuff like that. But there are physical differences in golf cart batteries. So let's talk about those real quick. All right, there are GC2, GC8, and GC12. I told you that the batteries that I have are GC2s. So GC2s are 6 volts each, and you need 2 of those wired in series. All right, 6 volts. Now remember, everything you're going to run is 12 volts. So you have 2 GC2s wired in series at 6 volts. That means it's going to be 12 volts. GC8s are 8 volt batteries. GC8 for 8 volt. So the 8 volt is not going to really help us in any configuration where it's going to be useful. So we're not going to use GC8s. The reason why these batteries are all these different sizes or the different voltages and stuff, because some golf carts use 36 volts, some of them use 40 volts, stuff like that. So all these different sizes are meant for different type of golf cart setups. The GC12s are going to be a 12 volt battery. All right, so you see that GC12 is a 12 volt battery, GC8 is an 8 volt battery, but GC2 is a 6 volt battery? Well, GC2 is a 6 volt battery, and the only way to make you remember the GC2 over the GC8 and the GC12 is the fact that you need 2 of them wired up. So GC2 for 2 batteries, GC8 for 8 volts, and GC12 for 12 volts. I recommend the GC2 batteries, specifically the Duracell that I have, and it with the chemistry and everything, it just seems to work better in a bank. Now, if I haven't bored you to tears yet talking about all the different sizes and the technical stuff dealing with the battery, now we're going to go into some electrical concepts and jargon. Okay, so please stick with me here because this stuff is important, and hopefully I don't nerd out on this stuff because this is kind of the field that I'm in. So I'm going to go ahead and try to equate all of this stuff to what you can use to try to give you a concept. All right, the first concept is the concept of voltage. All right, the concept of voltage. Voltage, you have at your home it's 120 volts. In your car it's 12 volts. Your small batteries are 1.5 volts. Your bigger batteries are 6 volts and 9 volts. So all these different voltages for all these different types of batteries. Well, voltage is a potential. All it is it's you got a bunch of electrons on one end of a battery and it's trying to get to the other end because it wants to equalize. So think about the fact that you have two tanks. One tank has higher level than the other tank, and you put the tanks side by side. If you connect the tanks together, they want to equalize. So one tank will equalize with the other tank, making them the same level. Well, the battery is like two tanks inside of this battery, okay? And they want to equalize. So what you're going to do to equalize this battery is you connect a circuit in there. And if you put a really tiny pipe in these tanks to equalize them, then you're going to get less water flow. And it's going to take longer for these tanks to equalize. All right, so the smaller the pipe, the larger the resistance to water flow, the less flow you're going to get. The longer it's going to take those tanks to equalize. Now, if you get a big pipe, then it could be very quick. All right, so are you staying with me here? All right, let me try to equate this to electricity. So that pipe is like the resistance. So let's say we put a valve in that pipe and we throttle down on that valve so that there's very little flow. That valve is providing resistance, and the resistance lowers the water flow. So that valve is resistance, and that water flow is current. And then the pressure of the water in the tanks is voltage. Pressure drives the equalizing of that water. Okay? So pressure is voltage, the water flow would be current, and the resistance to the water flow would be resistance to electrical current, if we equated that stuff to an electrical circuit. So voltage is measured in volts, current is measured in amps, and resistance is measured in ohms. So as you throttle this valve down, remember, I'm equating this to an electrical circuit. I'm not saying that these are the things that we're going to use in a water circuit, but it's easier for people to wrap their heads around this. That pipe that we're talking about is our entire circuit. And these two tanks is our voltage. Okay? If you want, you can connect the tanks at the top where it doesn't have a lot of water or anything like that that can equalize through it, and call that one battery. Okay? These two tanks are the one battery, and that pipe is our entire circuit. So throw whatever you want on that pipe. That's our circuit. Voltage is volts, current is amps, and resistance is ohms. If you have 1 volt, you will push 1 amp through 1 ohm of resistance. Okay? So it's that simple to remember. 1 volt with 1 ohm resistance will provide 1 amp of current flow. So let's think about this. Let's say 1 volt of that water pressure, quote unquote water pressure, and then 1 ohm of resistance given by that valve will produce 1 amp or 1 gallon per minute of flow through the pipe. All right, I hope you understand sort of voltage, current, and resistance, okay? Now, instead of a valve, we're going to have resistors, we're going to have pumps, we're going to have things like that. All right? Current flows on all legs. Current flows on all legs. So the neutral leg that doesn't have a potential, or at least you all think that it doesn't have any potential, it still has current flow. So you still have current flow and electrical flow in your neutral wire, which is why you're not supposed to have a neutral wire going to ground. Will the stuff still work? Yes, it'll work, but don't do it. Let's talk about power now. All right, if you took the pressure and you took the amps, or you took the pressure of the tank and you took the water flow and multiplied those together, you're going to get your hydraulic power. If you take the voltage, which is the equivalent of the pressure, and you take amps, which is the electrical equivalent of flow. Sorry, I started coughing there. Where was I? If you take voltage and you multiply that by amps, you're going to get watts, and that's your power. Power can be measured in watts. There are different types of power, but we're only going to talk watts here so we don't confuse anybody. So 1 volt pushing 1 amp through 1 ohm resistance equals 1 watt. Okay? Do you get that? So wattage is voltage times amps. So if you have 2 volts and 1 amp of current flow, it's 2 watts. 2 volts with 2 amps of current flow is 4 watts. Why is this important? Because everything is measured in watts. And you need to remember this. You need to remember the relationship of voltage and amperage with watts. All right? You really do need to remember that. Now let's do some really basic algebra here, and we can say that wattage or power, which is watts, divided by voltage, which is volts, equals our current, which is amps or amperes. Okay? So if you want to know the current of a system and you have the watts and the volts, you just divide volts or just divide watts by volts and you're going to get amps. All right, and that's important because every time you use a converter or an inverter, and you're going to learn quite a bit about inverters, every time you use one of these, you're going to end up with watts, but you've got to know how many amps you can pull. All right, and the reason why the amps that you're pulling, when everything is measured in watts, why is amps important? Because the capacity of your battery is in amp hours. All right? The capacity of your battery is in amp hours. How do we figure out amp hours? An amp hour is 1 amp for 1 hour. That's simple. All right, that is real battery capacity. It's rated in amp hours. So you've got to get from watts to amps in order to figure out how long something with a specific amp hour is going to last. So let's say you have a 200 amp hour battery. Well, that means that you can go 10 amps for 20 hours, right? Amps times hours is amp hours. So if you have a 10 amp draw on a 200 amp hour battery, you can go for 20 hours. 200 amp hours can go 20 amps for 10 hours. 200 amp hours can go 40 amps for 5 hours. Now, this isn't 100% true. Okay? This is just for for the ease of understanding. This is for ease of you understanding exactly what this stuff is. The fact of the matter is a battery is chemical. And with chemistry, in these batteries, a slower draw is more efficient. So that 10 amp hours is actually going to be more efficient than pulling 40 amp hours. So the 10 amp hours, if you're pulling for 20 hours, it may actually pull for 20 hours. If you're pulling 10 amps, it may actually pull for 20 hours. But if you're pulling 40 amps, it's probably not going to last 5 hours. It's probably going to be slightly less. Okay? This is what you need to understand. And some battery manufacturers do understand this, and they will tell you what their draw is at different amps, or what their capacity is at a different amp draw. All right, so just to make sure that I didn't confuse you, and we're going to recap real quick. The voltage is the potential. It's all these electrons that want to get to the other side. Your current is the speed at which these electrons get to the other side, or the pipe. You can think of it in pipe. The resistance is we are putting something in the way of all these electrons to make them slow down so that they can't go at full speed to the other side. And power is volts times amps. Otherwise, the amount of electrons trying to get over there times the speed at which they're going over there. And then amps can be measured, or amps can be figured out from watts divided by system voltage. So a 400 watt thing on a 10 volt system, which we're not going to use 10 volts, right? We're going to use 12 or 120, but 400 watt thing at a voltage of 10 volts is going to equal 40 amps. Okay? And then the capacity of the battery is amp hours, which is just amps times the amount of hours that you're drawing that amps. Now, if I didn't confuse you enough and give you all the jargon that you needed to figure things out for a battery that is in amp hours, I'm going to confuse you even more and talk about what's called reserve capacity. Reserve capacity, in someone's well-meaning attempt to make things a little bit more easy for the common consumer, they made it more complicated. So it's kind of like Congress. They try to make it easy and they make it worse. It's like the IRS. The reserve capacity is how long it's going to last based on an assumed current draw. So the amps that we're going to draw, the reserve capacity is usually in minutes, and it's going to say you can operate this battery for this many minutes when we assume that a specific application for this battery. So like a marine battery for a trolling motor, let's say that the marine battery on a trolling motor has a reserve capacity of 210 minutes. But then you've got a golf cart battery, which is larger, physically larger than this marine battery. You have a golf cart battery with a reserve capacity of 120 minutes. Which one's better? I mean, the marine battery has a reserve capacity of 210 minutes. The golf cart battery has a reserve capacity of 120 minutes. You tell me which one's better. The marine battery, right? Wrong. The marine battery is not better. The marine battery is assuming that you're using a trolling motor, which has about a 25 amp draw. Okay? And the golf cart battery is assuming that you're running a golf cart, which has a 75 amp draw. So it's drawing from that battery 3 times more current or more electrons. So to put some math equations to this, let's figure out the amp hours. Take the reserve capacity, divide it by 60 because you got to get minutes into hours, okay? So for the marine battery, take 210 minutes divided by 60 gives you hours. Multiply that by the assumed current of 25 amps, and it gives you 87.5 amp hours. You take 120 minutes for the golf cart battery, divide it by 60 to get hours, multiply that by 75 amps. That's the assumed current draw on this golf cart, and it's going to give you 150 amp hours for that battery. So 210 minutes reserve capacity is actually a 87.5 amp hour battery, and 120 minute reserve capacity is actually 150 amp hours. The golf cart battery has a smaller reserve capacity, but because it's assumed that it's drawing 3 times the current, it actually has a higher amp hour. It's actually almost double. So this is where they confuse everybody now. So what you want is you want to look at the battery, and you want to look and see what the reserve capacity is on these batteries at what current. Because sometimes these batteries will have the current that they assume on these batteries. If they don't have a current on the battery, you want to go ahead and assume 25 amps for a marine battery and 75 amps for a golf cart battery, and that will get you in the ballpark. I hope that you guys are still with me and not sleeping. That would be bad because a lot of you guys listen to me in your car. So don't sleep. If you have to, pause it, listen to something else, and come back whenever you're not so tired. But we're going to move on to the next thing, and I think this is the last actual technical jargon we're going to cover. This is depth of discharge. And this one's a pretty easy concept to understand. Depth of discharge is really just a percentage of the battery used. So let's think about it this way. 30% depth of discharge is 70% of the battery capacity left over. Any depth of discharge above 50% is called deep cycling your battery. Does that term seem familiar? Deep cycling your battery. Deep cycle batteries. It should be familiar. We covered it. So a car battery will do 100% depth of discharge about 15 times. Remember when I told you earlier about 12 times you could go from full charge to full discharge? Well, that's 100% depth of discharge. So it'll go 12 to 15 times. But your deep cycle battery will go 100% depth of discharge, full charge to full discharge, about 150 to 200 times. So 50% depth of discharge, it'll go, and we're just going to make this math real simple. I'm going to do basic math, and it's not going to be 100% accurate. Understand this. But if you can go 100% depth of discharge on your deep cycle battery 150 to 200 times, and you can assume that you can go about 50% depth of discharge about 300 to 400 times. And then you can go 25% depth of discharge about 900 to 1200 times. All right, so remember that if you discharge your battery less and you keep it charged up, the less you discharge your battery, the longer it will last. That's the most important thing to learn out of the depth of discharge jargon, is that if you discharge your battery less, it will last longer, and that deep cycle batteries are designed to cycle deep. If you go below, or if you go above 50% depth of discharge, that is called deep cycling your battery, which is exactly what a deep cycle battery is designed for. Although it's designed for it, does not mean that you should do it every time. However, the reason why you have that battery there is in case the power goes out, and if the power goes out and you need to discharge it, you need to deep cycle it, you do that. That's what the design is for. That's why you have that battery. That's why that battery is designed. All right, so between flood lead acid and AGM batteries, I already talked about all this. You're going to choose economy or safety, right? Flood lead acid battery is going to be more economic. You're going to get more capacity for your money, and an AGM battery is for safety. And we're not even going to do sealed lead acid because sealed lead acid is a waste of money and a waste of time. We're going to either get flood lead acid or AGMs. Flood lead acid is more economic. AGMs are safer. So if you have kids and you want to keep this bank in your living room and you don't want them to be hurt, well, then you're going to go ahead and use AGM batteries. Otherwise, go ahead and get flooded lead acid batteries. And remember, we already talked about deep cycle batteries the deep cycle batteries can be mostly are flooded lead acid batteries, unless you specifically get an AGM battery, and that's called an AGM battery. But if you get a marine battery that doesn't say marine AGM or marine absorbed glass mat, it's a flooded lead acid battery. If you get a golf cart battery, it's and it doesn't say golf cart AGM or golf cart absorbed glass mat, it's going to be a flood lead acid battery. So here you're choosing economy versus safety. My recommended batteries that I use is, and I've got links, I've got the golf cart flooded lead acid battery, I've got a marine flooded lead acid battery, and I've got an Optima AGM battery as well. I don't know why I wrote down gel cell battery in my show notes, but it is an AGM. So let me go ahead and change that now. All right, so the Optima AGM battery is probably one of the better, and it's well-known. It's a well-known AGM battery. So all three of those are linked in my show notes. All right, let's go. We've decided that we're going to use the GC2. I've already recommended it for you guys. So we've decided GC2 batteries if we're going to use golf cart batteries versus a marine battery. All right, a GC2 battery or a golf cart battery is about 64 pounds each. You need two of them to make 12 volts. So it's going to be about 130 pounds. That's 130 pounds of dead weight. So think about picking up a 130-pound person, but you can't throw them over your shoulder. You have to hold them in front of you. That's what you're doing with these batteries as dead weight. So in order to move the stuff, you're basically, like me, I'm stupid, so I'll probably break my back doing it. I'll just pick it up and I'll move it. And yeah, it's heavy as crap, but I'm hard-headed and I'm an idiot, so I'll probably move it and hurt myself. But if you don't want to hurt yourself, basically what you're going to do is you're going to have to disconnect these batteries every time you want to move them. So this is for more of a permanent option. They have more capacity. They have slightly better chemistry and thicker plates than a marine battery. All right. There's more room at the top of a GC2 battery. And the reason why there's room at the top is so that you can overfill that battery. All right. And there's all this open space at the bottom as well, so that all this plate scale, when the plate scale builds up because of all the chemical reactions and stuff that this battery goes through, it'll form scale on these plates, and that scale can drop to the bottom, and it's not going to short out between plates. All right, so let the scale fall to the bottom. It won't short out the plates, and the battery will continue to function. The caps are easy to remove to add water in most GC2 batteries. There are two types. There's one of them that all it is one handle. You twist that one handle, it lifts all three caps. Remember, I said these batteries have three chambers. It'll twist all three caps when you twist this handle, and you just pull it off, and you can refill it. Hold on one second. All right, I'm back. I had to cough. So it's easy to remove. The other one has just three caps, but it's almost always easy to remove. these lids so that you can add water. And these lids hold pretty darn well, but it's still a flooded lead acid battery, so obviously you don't want to tip it. All right. Now, these are better for stationary use, like I said, such as a home battery bank, or if you're going to make a permanent mobile battery bank, then you may go with these batteries as well, because these things are tough. They're meant to be on golf carts with a bunch of drunk people driving these golf carts, bouncing them all over the place, and driving them into rivers, okay? So these batteries are good batteries, and they are of durable construction, so that is why if we're going to use flooded lead acid battery that's not a marine battery and we want something that's durable, we're going to go with a golf cart GC2 battery. Now, for the marine batteries are about 50 to 60 pounds each. Now, that's pretty darn heavy. It's almost as heavy as one golf cart battery. But the thing is they're 12 volts. Because they're 12 volts, you only need one to actually use. All right, if you wire these up, you're going to wire them in parallel, but you only need one to actually use stuff off of it. So now all you got to do is move one battery, and that battery also has a handle. So now you've got a handle, and it's a lot easier to move 50 to 60 pounds when you have a handle. The plates in a marine battery is actually kind of a sponge plate. It's like a sponge. I don't really know how to explain this to you, but the plate is kind of like a hard sponge material, okay? Instead of just being one thick solid plate. So it's not quite as robust of a plate. It's got a little more surface area, but it's not quite as robust as a golf cart battery. But it is still a deep cycle battery, so it still has a decent plate design. All right. These, you've got to pop the caps. If you're going to refill these, you have to pop the caps in order to get water back into it. All right. Now, you only refill batteries with distilled water. Okay? If you have to add water to a battery, you add distilled water. Okay, these are better for mobility so that you can tote them back and forth. And if you have a car, you can take this battery off of your table, move it into your car if you got to go somewhere, and use the power from this battery. All right, so it's better for mobility, but it's harder to do maintenance on because you have to pop the cap with a screwdriver instead of just twisting it right off like you would a golf cart battery. So it's really going to be up to you whether you want to use these batteries or not. I was going to talk about chargers. I'm not going to talk about chargers because I'm reaching close to an hour now. I'll talk about chargers on the next one, even though it would have been better for me to talk about chargers on this one so that I could, just for the flow of the podcast, it would have been better for me to just talk about chargers now. But in order to keep these in bite-sized pieces, I have to stop whenever I start seeing the clock get up to about an hour. So I'll just talk about some precautions real quick with batteries, and then I'll go ahead and I'll end it, and I'll see you guys next week, okay? So you're never going to precautions for the batteries. You do not want to short between a plus and a minus, okay? All right, the difference here is if you are running batteries in series, then yes, you'll have a plus of one battery going to the minus of the other battery, but that's it. It will be one connection between these batteries, but all you're doing is you're putting them in series, so it's like having one bigger battery. What you don't want to do is short between the positive and the minus. Batteries have this thing called infinite amperage. Now, here's the thing. Because of the chemical reaction, it's obviously not going to be infinite, but in the theoretical world, a battery has infinite current capacity. So how much is going to be shorted between the positive and the minus? Just remember, all of it. You want to see a wrench glow red hot, and you want to see a battery explode? You go ahead and short between the plus and minus terminals of your car battery, and your wrench is going to glow red hot. It's going to have you're going to actually see when you're all done, if it's not welded to the terminals of your batteries, you will see pits being taken out. You will see your wrench will have metal removed from it because there's so much current. It's like welding. And not only that, but your battery can explode. So don't short between the plus and the minus. All right, never place a 100% charged battery with a 0% battery. Now, that's the extreme, but I would say always charge your batteries up. If you can, always charge your batteries up to 100% before connecting them together. I always keep sets of my batteries connected. If they're 12 volts, okay, you can disconnect them. But if they're 6 volts, I don't ever disconnect two 6-volt batteries. I keep them where I have voltage of 12. The reason for that is so that you can charge them up to 100%, charge your other batteries up to 100%, and then connect them together. Why don't you want to place a high charge battery with a low charge battery? Well, it's almost like shorting between the plus and the minus. Let me bring back those tanks that I was talking about. You have a tank that's 100% full and a tank that's 0% full. You tie those together, the 100% full tank is going to push the water into the 0% tank. Well, unfortunately, in the battery world, with the chemical reactions inside, and in the electric world, with the limited amount of copper in a wire, this is very detrimental. Number one, you're drawing an insane amount of current. This is detrimental to the battery. You're charging with an insane amount of current, which is detrimental to the other battery that's 0%. And it's also detrimental to the current carrying conductor, which is the copper or aluminum, depends on where you get your wire. You're going to keep your batteries off of the cold concrete. All right? Cold concrete will not discharge your battery. Okay? What it will do is cool off your battery, and it will reduce your battery performance. That's why they tell you don't put your battery on the ground, and they tell you don't put your battery on the cold concrete in your shop. You don't want to do this because you reduce the performance of your battery. A warm battery is a happy battery, and a warm battery produces better. You want to keep these batteries, let's say, around 85 degrees. A battery at 85 degrees is especially happy, and you will get best performance from a battery around this temperature. Now, I'm going to cover one more thing with batteries. I know on my last podcast, someone made some comments on my show notes. And I am glad that you made that comment. And I'm glad that you did the research that you did and you sent it to those comments. Now, there are a couple different things that you need to understand when it comes to batteries. A car battery generally has a liftoff valve. A car battery will have a liftoff valve. And my car battery has a liftoff valve that is connected to because my battery is actually inside my car, inside the people space, and it's connected to a line that exhausts outside the car. Why do they have that liftoff valve? It's like a little pressure valve, and it's because the buildup of hydrogen. Okay? It's a buildup of hydrogen. But with these deep cycle batteries, a lot of times you don't have a liftoff valve. Why is hydrogen such a big deal? Everybody's concerned about hydrogen building up in their house. Well, you don't want to put your battery in a place where hydrogen can go up into where it's going to go up into an area of the room where there's absolutely no flow or anything like that to let the hydrogen get out. Okay? Where, people know that smoke can accumulate in certain places. People know about carbon monoxide accumulate in certain places. And yes, hydrogen can too. But here's the thing. it doesn't usually build up in the room. Now, there's another reason why you don't want to use a car battery, because you let all the hydrogen escape. You don't want to build up, or the hydrogen does not want to build up inside a typical room. A basic room. If you have a battery in your garage, or you have a battery bank in your living room or something like that, this hydrogen is not going to escape. And I guess I didn't even mention, in the AGM battery, it has a recombiner. It's a catalyst so that the hydrogen and oxygen inside the battery can recombine into the water. Okay? So there is a recombination catalyst inside your AGM batteries, because your AGM batteries don't let anything out. You can put those anywhere. But your typical flooded lead acid battery, the deep cycle batteries that we're going to be using, you can keep them inside. If you're not worried about your kids messing with them, you can keep them inside of your room. As long as you have a small amount of flow, airflow, in a room, you are 100% okay. The speed at which hydrogen escapes, it goes screaming out of your room. If hydrogen actually, the small amount of hydrogen that comes out of a battery will escape at 2,000 meters per second. Think about that. That's 2 kilometers per second. All right, that's how fast, that's screaming out. It wants to instantly, it instantly wants to just spread around the entire atmosphere of the globe, okay? No joke. Hydrogen is that fast, and it leaves it that fast. And it's because of the specific gravity of hydrogen versus that of typical air. Hydrogen is much, much lighter than helium, and we all know how helium does in air. All right? So if you have, let's say you have a balloon of air or a beach ball. Take a beach ball of actual air and put that and try to sit on top of that beach ball in the ocean. And you're going to fight that beach ball, and it's going to push up, and it's going to come up quick. Well, that beach ball in water is nothing compared to hydrogen in regular air. It escapes. It tries its darndest to escape. It doesn't want to stay. And the amount of hydrogen that comes off of one of these batteries is very minimal. All right, so you don't have to worry a whole lot about that. What do you have to worry about with the hydrogen? The biggest problem with hydrogen is the fact that you may not have your batteries sealed up where the caps are, where you add water, stuff like that. You may not have them sealed all the way. So make sure your caps stay tight. Make sure your caps stay closed. Okay, because you don't want hydrogen escaping the battery itself. The biggest problem is during maintenance and when you're opening the battery or connecting a charger. So you don't want to, let's say that a little bit of hydrogen leaks around the cap because the cap is not on tight. So a little bit of hydrogen is going to leak around. If you have a very loose connection on your terminals, then they can make little sparks. Let's say that you plug in your battery charger into your wall and you connect it to your battery, and it has been leaking hydrogen a little bit around the lid. So a little bit of accumulation occurs around the lid, or just a little bit of flow of hydrogen out of that lid. And then that spark catches that hydrogen on fire because there's oxygen in the air, and the hydrogen combusts, and that combustion gets underneath the lid of the battery, and it will explode that battery. That is your biggest danger with the hydrogen. So make sure your caps are on tight for one. And never connect or disconnect anything with the cap open. And never connect or disconnect your charger while it is on. Never open your battery with your charger connected. And especially with your charger connected and on. Never connect or disconnect any load to a battery an inverter or anything like that when it is on or when the caps are open. So make sure that all your connections are tight on your battery. Make sure that you're not drawing anything from your battery, like none of your loads and none of your chargers are connected to your battery when you open them up. This will keep you from exploding your battery in your face and destroying your face. It'd be nice not to destroy your face. So just make sure connecting and disconnecting does not mix with opening of your battery. Current flow, in other words, charging or discharging your battery, does not mix with opening your battery. And make sure your lids are always on tight, and make sure all your terminal connections are tight. And like I already said, AGM batteries have a catalyst, a platinum catalyst in them that recombine the hydrogen and oxygen back into water, and they don't leak. And with that, this was Ken Jensen of theprepperpodcast.com teaching you strategies on self-reliance so that you can build a more resilient and more enjoyable life. Have a wonderful week. This is Ken signing out.